Alright, so in this video what we're going to do is we're going to take it a few steps further with these electron configurations. In the previous video, what we were talking about was any electron that we have in any atom is going to be at specific spots, basically, specific orbitals within that atom, okay? And so we've got different energy levels, first, second, third, fourth, and we can have fifth, sixth, and seventh energy levels as well. And then within each energy level, we can have these different types of orbitals. So we can have s orbitals, we can have p orbitals, we can have d orbitals, and we can have f orbitals. And within each of those sublevels, there's multiple different orbitals that you can be in. So if I'm in a s sublevel, I can only have one orbital. If I'm in a p sublevel, I can have 3 different orbitals. D can have 5 and F can have 7. Now we kind of drew it out like this. This is where we left off, was looking at this. And so for example, if we wanted to show the electron configuration for, let's say, carbon, we saw that as the electrons start filling in those shells, start filling in those orbitals for carbon, they're going to start at the lowest energy and then they're going to work their way up to the higher energy levels from there. So we see that here's our first level with its one orbital, because remember, again, just to reiterate, so that first energy level can only hold just that one s orbital, and that's it. So for carbon, and if we go to carbon real quick, let's see, carbon's right here. It's got 6 electrons. So if I come back over here, I'm going to be showing 6 electrons. 6 electrons for carbon. So I'm going to have 6 electrons that are going to fit in these different orbitals here. So the first electron is going to start right here at the lowest energy level. We put an arrow. That is what we're using to show an electron. And remember, it's one of them is going to be pointing up, one of them is going to be pointing down, because in each orbital they're going to have opposite spins. So for this 1s orbital here, here's the 2 electrons in that 1s orbital. One of them has a positive spin, one of them has a negative spin. And we also said that each orbital, no matter if it's in a p level, s level, or a d level, or f level, you can only have 2 electrons in each orbital. Okay, so for carbon, here I've got 1, 2. I've got 4 more electrons to fit in there, so I can't fit any more in the first energy level. This is all I can fit in the first energy level is 2, so I got to jump up to the next highest energy level, which is the 2s orbital. So here I can fit 1, 2 more. Okay, that's 4 electrons. I need to get to a total of 6. I can't fit any more in the s orbital. I'm still in the second energy level, but I can't fit any more in the s orbital. That s orbital can only hold 2 electrons. So then I jump up to the 2p orbital. Now remember that in the p sublevel, I can have 1, 2, 3 different orbitals in the p sublevel, and each orbital can hold 2 electrons. So here's how we're going to start filling these in. So I've got 1, 2, 3, 4. I need to get 2 more electrons. So 1 electron is going to go in one of these orbitals, and then another electron is going to go in another one of those orbitals. And there's my electron configuration for carbon. So if I want to write that out, it would be like this. 1s, and then we've got 1, 2, 2s, 1, 2, and then 2p. I've got 2 electrons out of these 3 different orbitals. 1. Now, another way to write this is an orbital diagram, because we're showing the different spins of the electrons in each orbital. But another way we can write this, an easier way to write this, is we can just write the number of electrons in each one. So for example, for this it would just be 1s2, because I've got 2 electrons in there. 2s2, and then 2p. And then how many electrons do I have in this entire p orbital? All of these p orbitals, I have 1, 2. So I put a 2 there. So this number up here is just denoting how many electrons do I have in that orbital, basically. Okay, so we can, instead of writing it like this with all these arrows in here, we can just write it with the number. So that's what we learned in the previous video. Now let's take it a step further, because we didn't really get past, we did not get past the d orbitals. We only went up to element 18, which is argon. So that gets us to basically the end of this 3p. So that would be 18 electrons, gets us to the end of the 3p here. But after that, we have to start filling in the D block and things like that. And so things get a little trickier once we get up there. So let's do another example here real quick. Let's say we do let's do number 18 actually. Let's do argon, because that'll be a good reference for us. So if we're looking at argon, all right, and we're going to write out the electron configuration. So argon has 18 electrons. So let me start filling in the electrons here up to number 18. So we've got 1, 2, 3, 4, 5, 6, 7. Now remember, when we have more than one orbital like that, we're going to, if there's open orbitals, we put the electron in there first before we start doubling up. Okay, so notice I put a single electron in each one first, and now I can go back and start doubling up. So that was 4, 5, 6, 7, 8, 9, 10. Okay, I'm out of space in the 2p orbitals here, so now I got to jump up to the 3s. That's the next highest energy level. So that was at 10, 11, 12. Got to go to the next highest energy level, which would be the 3p orbitals. So we're at 12, 13, 14, 15, 16, 17, and 18. So there's my electron configuration for argon. Okay, so again, if I were to write that out the shorter way that we just talked about, so 1s2, 1s2, 2s2, 2s2, 2p, 1, 2, 3, 4, 5, 6, 2p6, 3s2, 3p6. Okay, there's my electron configuration. Basically just showing where are all my electrons. I got 6 electrons in the 3p orbitals. I've got 2 electrons in the 3s orbital. I've got 6 electrons in the 2p orbital, so on and so forth. Okay. Now, if I were to go after argon in the periodic table is potassium and calcium right here. So here's argon. If I were to go to the next 19 and 20 here, let's look at calcium for example. Okay. If I were gonna do a electron configuration for calcium, so this has got 2 more electrons than argon. Now you'll notice that if you look at this diagram, notice that I've got the 4s. I've got the 4s orbital here. It's lower in energy than the 3d orbitals. So your first guess might be to say, okay, those next electrons are going to go to the 3d and then go up to 4 because, well, 4 is greater than 3, so 4 must be a higher energy than the 3d orbitals, and that's actually not what happens. The 4s actually has a little bit lower energy than the 3d, so what's going to happen is those electrons are going to fill this first and then go to the d orbitals, okay? And we'll talk about this more in a second, but like, so essentially what we would get is, so right now we've got 18 electrons showing in here, so I'd have to add 1, 2 more here, and that would get us to 20, and so that would be the correct electron configuration for calcium. So it would be all of this, right? So 1s2, 2s2, 2p6, 3s2, and 3p6, and then 4s2, And then after calcium, when I start getting into the transition metals here, then I start filling in this 3D orbitals here, okay? And so that can be a little confusing. And so if we think about it like this, let's go to this image here. If you look at this periodic table, this is a blank periodic table, and it's breaking up things into, notice it says the S block, which are these purple ones here, and helium right here would be included in that. We've got the P block, which is all of these elements over here. We've got the D block, which would be the transition metals here in the middle. And then we've got the F block elements, which are those lanthanides and actinides that are kind of down here at the bottom. And so what this is showing here, and this kind of helps think about our electron configurations, it's showing us where certain elements are filling in those different orbitals. So if I'm an element over here, for example, in any of these green ones, if I'm an element here, the electrons that I have are filling in the p orbitals. During any of this over here, the electrons are filling in the p orbitals. If I'm any of these elements here in this purple, then the electrons are filling in the s orbitals. If I'm down here, any of these elements down here, then I'm filling in the f orbitals. Okay, and now think about this, right? So if we go back to this, and we look at how this 4s is going to fill up before the 3d, and the reason is, let's think about it. Here's calcium right here. So let me get a different sized thing here. So if we look, here's the first level right here. This is the first level on here. So this is 1s. This would also be a 1s, right? The s block. Then we go down to the next one. This would be 2s, our second level, but this is our s sublevel. This would also be 2s, because remember, I can fit 2 electrons in that 2s orbital. But then after I get through with that, I jump over here. Now I'm in the p block, and so second level in the p orbitals. And now remember that the p orbitals, let's jump back to this real quick. The p orbitals can hold 1, 2, 3, 4, 5, 6. And that makes sense with the periodic table, because if you look, there's 1, 2, 3, 4, 5, 6. So during this time right here, I'm filling in the p orbitals, right? And then if I have to continue to add electrons, I can jump down here. Now I'm at the third level in the s subshells. Remember, the s can only hold 2 electrons, which is why there's only two columns here, right? And then after I've got those full, oh no, I lost my pen. There it is. After I've got those full, then I can jump over here. Third level, p orbitals. And once again, I can fit 6, right? So if I come back over here, 3p, 1, 2, 3, 4, 5, 6. Okay? Now, after I get through filling that, and I jump down here and I do the 4s, the 2 electrons in the 4s orbital, and then I get to the d block. Okay? And you might be thinking to yourself, well, why isn't it 4d then, right? We're at the 4th level on the periodic table, so shouldn't it be 4d? But remember that what we talked about in the previous video, where does that d orbital first show up? That d orbital first shows up in the 3rd energy level. It shows up in the 3rd energy level first. And so over here, what we would see is that this would be the 3d. The 3d orbitals will be filling during this time, during that. So basically, that's why that 4s orbital will fill first, and then it will drop back down to the 3d orbital and start filling that. And then right here, I'd still be working my way up in the p block here. So it'd be 2, 3. This would be 4p, and then I'd start filling in the 4p orbitals. And then we keep this pattern going. So then jumping down to the next one. So keeping in line with the s block here, it would be 5s. There's 2 electrons that'll fit in the 5s orbitals. And then this would be 4d. The 4d orbitals would begin to fill. And remember, let's count this up. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which again, if we look at the d orbitals can hold, there's 2 electrons in an orbital, 2, 4, 6, 8, 10. And so that lines up with that as well. And so if we keep this pattern going, so if the 4 d orbitals would begin to fill, then 5p. Then we get down here, it'd be 6s. The 6s orbital would begin to fill. Now here it gets a little trickier. So the 6s, and what doesn't show on this periodic table, I should have got a different periodic table for this, but right here, you might see on your periodic table, there's it'll say like the lanthanides and actinides. That's because this whole block right here essentially is supposed to fit in that spot right there. So really this whole periodic table this should be shifted to the right, and this should be in this spot here. But it just is easier to print on a sheet of paper if we take that out and we put it down here. But this row would have to fill first in here, and then this row. So in other words, you'd be filling the 5p orbitals, you'd get to the 6s orbitals, and then before you go to this 5d here and start filling in those electrons, you would have to first fill these electrons here, because this whole row should be in between this 6s and this 5d, should be this whole row right here. And what block would this be? Well, it's an F, but would it be 1, 2, 3, 4, 5, 6? What number would it be? Well, we come back over here, and we said that where does the F block first show up? The F orbital first shows up in the 4th energy level. So right here, this would be 4F. So you'd have to fill the 4F orbitals, then fill the 5d orbitals, then the 6p orbitals. Then we can jump down here. This would be 7s would be filling next, 7s orbital. Then we'd have to come down here again, because this whole column, this whole row should be in between the 7s and the 6d, would be right in here, would be this one. This would be the 5f. So the 5f would be filling first, then the 6d orbitals would be filling, and then the 7p orbitals. And so that's the progression of energy as you're filling in those electrons in there. So let's say, for example, let's pick an element that's somewhere in here. Let's do iron. Iron is, let's see, I gotta look at a periodic table that iron is 1, 2, right here. Iron would be right here. So if we're going to do an electron configuration for iron, well, let's just look at where it is in the periodic table and we can write it out. So for iron, we've got all of this that comes before it is full. So I've got the 1s here, 2, 1s, 2, those electrons are full. This is full, this is full, this is full, this is full. So I can just write those out. So I've got 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and then I get to my d block here, and I know I'm going to be in the d orbitals here, so I'm going to count how many electrons I have in the d orbitals. I got 1, 2, 3, 4, 5. So 3d5, and that would be the electron configuration for iron. Let's do one where we've got somewhere down here where we have to include the F block in this. So let me erase iron here. Whoa, gotta get a smaller eraser. Let's try, how about we'll do 2 below iron, osmium. So for osmium, so again, all of these will be full. I'm going to write out the full notation. This is going to be a long one, but I'm going to do it. This is to make a point, basically. So I've got 1s, 2, 2s2, 2p6, 3s2, 3p6, 4s2, and then we get to the D block. So 3d10. I can fit 10 electrons in there. So 3d10. Let me put a mark on here where we're going. We're going right here. This is where we're trying to get to. So 3d10, 4p6, 4p6, 5s2, 4d10, 5p6, 6s2. Now remember, once we get right here, this is where that 4f row is going to be. So in between 6s and 5d is my 4f row. Now there's going to be 14. There's going to be 14 electrons that can fit in there. So it's going to be 4f14. And then I can get to my D block here. So there's 1, 2, 3, 4, 5 electrons in that orbital. So 5d5. And there's my electron configuration where all the electrons are in osmium right there. Now, you might be thinking to yourself, this is stupid. Why would I have to write out this whole thing for this electron? That's just ridiculous. Look at how long this is. I mean, what if I got down to elements that are down here? I mean, this thing is going to go on forever. And you're right. There's a better way to write this, and it's going to be a noble gas notation. Now, remember that the noble gases are over here along this column right here. And what we can essentially do is we can pick the closest noble gas that comes before it, and we're going to assume, since we know that all of these orbitals that come before this element, we know that this orbital, this 6s orbital, this 5p orbital, this 4d orbital, all of these orbitals that come before it are full. They're full of electrons. So I don't really have to keep repeating that pattern and write this whole thing out, since I know up until I get to the 5d orbital here, I know that all of it before it is full. So what I can do is I can come back to the next, I'm just going to work my way back to the next nearest noble gas. So here's the noble gas, the nearest noble gas that comes before osmium, which is this one right here, which would be xenon. Okay, so this is xenon. So I know that all of this up to xenon is full of those electrons. So what I can do is, instead of writing all of this, which would be up to the 5p6 right there, all of that is basically the electron configuration for xenon. So what I'll do is I'm going to compress all of this right here down to xenon, and I'm going to put it in brackets like that. Okay, and then I'm just going to pick up from there, and I'm going to write the rest of my electron configuration from there. So I'm at xenon, and that gets me to 5p6, and so then I'll just go from there. Then I can write, okay, 6s2, and then 4f14, and then 5d5. So if it asks for a noble gas electron configuration, it would be like this. So you'd use, so for iron, if we were to do another example, here's iron. The next nearest, actually, you know what? I want you to take a second, pause the video, and I want you to write a noble gas configuration for iron. Pause the video, see if you can figure out what that would be. All right, so I'm assuming you paused the video and you at least gave it a shot. So if we look at this, the next nearest noble gas, so I work my way back, the next nearest noble gas would be this guy right here, which is argon. So for argon, we would put argon in parentheses, and then we would work our way towards iron from there. So going from there, it would be 4s2, and then 3d, 1, 2, 3, 4, 5. And that would be the electron configuration, noble gas electron configuration for iron. So I hope that's not too confusing, but hopefully with that you should be able to do some electron configurations for some of these problems.